Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the project you hear about on the show, you'll need somewhere to deploy it, so you should check out our friends at Linode. With 200 gigabit private networking, scalable, shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. Go to dataengineeringpodcast.com/Linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of the show. Managing and auditing access to your servers and databases is a problem that grows in difficulty alongside the growth of your teams. If you're tired of wasting your time cobbling together scripts and workarounds to give your developers, data scientists, and managers the permissions that they need, then it's time to talk to our friends at StrongDM. They have built an easy-to-use platform that lets you leverage your company's single sign-on for your data platform. Go to dataengineeringpodcast.com/strongdm today to find out how you can simplify your systems. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data platforms. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss the Strata Conference in San Francisco on March 25th and the Artificial Intelligence Conference in New York City on April 15th, both run by our friends at O'Reilly Media. Go to dataengineeringpodcast.com/StrataCon and dataengineeringpodcast.com/AICon to register today and get 20% off. Your host is Tobias Macey, and today I'm interviewing Thomas Henson about what data engineers need to know about deep learning, including how to use it for their own projects. So, Thomas, could you start by introducing yourself?
Hi, so I'm Thomas Henson. I'm a Pluralsight author and involved in the data engineering community, and also work for Dell EMC in our unstructured data team. So I've been around data engineering and really around the Hadoop ecosystem probably for the last 6 years, since before Hadoop 2.0, and I've just been a part of that community and love it.
And do you remember how you first got involved in the area of data management?
Oh yeah, 100%. So going through college, I thought for a long time that I was going to be a DBA. So that's kind of what I was targeting. And so when I graduated, the job market being what it is, and it doesn't matter, what era, right, you're in, especially when you're getting out of college, you're having to apply for a lot of different positions. And I actually got my first role as a web developer. So totally different, right, than being a DBA. So, but I always kind of had that passion. And I guess I would be considered a full stack developer. So I did do some database management to some extent for our applications, but nothing too ingrained like a traditional DBA. And then, lo and behold, a few years later, there was a research project that came up, and I didn't know at the time that it was going to be a big data project, but I knew it was going to require a lot of information and just really take me outside my comfort zone. So I volunteered to get on that project, and it turned out we were using Elasticsearch at the time, and then we rotated into using Hadoop. So downloaded the Hortonworks sandbox, and I think Cloudera had one at the time too. And that was kind of my path. And went to my first, I think, Hadoop summit, and from there I just started looking and just really saw this community and really saw my opportunity to get into data from what I'd looked at in my college days. So haven't looked back since.
And recently you've started getting into the area of deep learning and experimenting with that. So can you start by giving a bit of an overview of what deep learning is for anybody who isn't familiar with that terminology?
Yeah, so from a data engineer's approach, I haven't really, I didn't really spend much time on the algorithms and just kind of focusing on some of the machine learning pieces and, that portion. And I'm not saying it was like kind of a dark box for data engineers, but it's not something that I really, spent a lot of time. Like, I was worried about being able to stand up our Hadoop cluster or stand up our environment, or writing at the time MapReduce jobs or Spark jobs, and those kind of pieces, and kind of left the data engineering to the data engineers. But slowly started looking into okay, well, I know which algorithms we're using. Let me find a little bit more kind of underneath the covers about what those are. And so started kind of having that approach to looking at it. But specifically, if you're looking from a data engineer's perspective or even a data science perspective, the real difference and key between deep learning and machine learning is going to be the use of neural networks. So you're using neural networks to be able to go through and analyze your data versus, with machine learning, it's a more of an approach where, hey, we're taking all these different feature sets. Like one of the famous examples is if to identify cats on the internet. And I don't know why that you want to be able to identify cats from YouTube videos. Maybe it just makes for amazing YouTube videos. I don't know, but that seems to be like the first use case. And so if you think about, the machine learning approach to how you're going to, identify a cat from a video is, you're going to program in the different features. So like, features as in, hey, what do the ears look like? Does it have hair? Even though there is hairless cats, but just you're going to assign those, right? The whisker length and some of those other pieces, and you're going to run those through your different algorithms. So if you're using SVD or if you're using some kind of decision tree, you're going to pick out the algorithm and you're going to test and run that through. And that's the machine learning approach. But from a deep learning approach, what you're going to do is you're going to have this labeled data set. And you can't have unlabeled data set, but let's just keep it with labeled data sets here. And you're going to feed those images of those cats through, and you're going to be able to identify and let the neural network decide, okay, this features or hair or the whiskers, what makes the biggest difference there? And you can kind of evaluate how that looks. So it's a different approach from what we've done for machine learning. But just as a data engineer, it was just kind of fascinating to me to kind of, I wanted to step back and take some time to really learn kind of what our data scientists and, on our team kind of go through to hopefully, make me a better data engineer so I, can understand algorithms and kind of go through that process.
And as far as your own experience with deep learning, I'm curious what set you down that particular path and what your experience has been with that so far.
So at the end of 2017, a couple of groups. So I do a podcast with some other people in the data engineering and the data analytics world. And so there were a couple of us, Aaron Banks and Brett Roberts. We were looking at doing a Coursera course and just being able to kind of go through it. And we wanted to do the most famous one. So like, the most famous machine learning course with, Andrew Ning taking everybody through. I think he's taught more people on the planet about that than probably anybody else. And so we were like, okay, this is the most popular course on the planet. Let's kind of go through it. And it was very hard. So, we kind of looked at it as like, oh, this is, an online course. This is something we can do together. And we'd record videos after going through it. But it really took me down more of a math path. And I guess I should have known that. But so, after kind of going through that and really understanding more about machine learning, just doing some work in my job at Dell EMC, I'm part of a group called the Unstructured Data Solutions team. And so, being a part of that group, there's a lot of things going on in the deep learning world that I was kind of challenged by some of my coworkers and the other business units to understand more about that. And so, I took what I learned in the machine learning area and kind of really applied that to what's going on from a deep learning. And so I started learning, more about TensorFlow and PyTorch and what's going on from a GPU specific basis and just kind of going down that path. So, it wasn't that I was targeting at first the deep learning. I just kind of thought it would be good for me to understand because I got, I would continually get questions as, somebody who's advocating out in the data engineering community, questions around data science. And so I just thought for me to be more well-rounded, that it would be good for me to be able to answer some of those questions or have a better understanding for it. And it just kind of evolved into, hey, we need to check out what's going on from a TensorFlow perspective. And I just kind of hadn't looked back for the last year or so.
And particularly from the perspective of a data engineer who's working on building out the infrastructure and the data pipelines that are necessary for feeding into these different machine learning algorithms or deep learning projects, what is involved in building out that set of infrastructure and requirements to support a project that is going to be using deep learning, particularly as it compares to something that would be using a more traditional machine learning approach that requires more of the feature engineering up front as opposed to just feeding in the labeled data sets for those deep learning algorithms?
So that's a good question. Like as you start looking at it and, kind of the way that I approach it, one with my learning is just kind of the way that I like to describe it is just, you think about, my experience from the Hadoop ecosystem, right? And like how does it differ, from what we're doing in deep learning to what's going on from a Hadoop ecosystem perspective. And you think about, in the Hadoop in the Hadoop world, your data is in HDFS or what we're trying to analyze. It's still, it's somewhat structured, or semi-structured, we call it, or, we'd call it unstructured data, but it was really, like still a lot of text data and other portions like that versus what we're doing from a deep learning approach is, we're talking about, mostly, image data or voice recognition, but just rich media, right? Like even video data. And that's really kind of one of the key portion. So with that, when we talk about big data and Hadoop, we were talking about large data sets, but now, on a deep learning side, we're talking about massive data sets, right? Because I mean, how much video data does it take to, create the next driverless car, right? We're still going through that and figuring that out. But I mean, you can just imagine, if you're doing any kind of simulations or anything like that, I mean, we're talking about lots of sensors and lots of data points. And so there's some challenges there. And then one of the big keys too, that's really kind of pushed forward deep learning and why you're seeing other projects from the traditional ecosystem. Like, so there's projects like Project Hydrogen, Submarine, and even what NVIDIA is doing with Rapids. They're trying to get more into the GPU. And so the GPU is giving you the ability to analyze data faster, even do ETL faster. And, that's really kind of accelerating it. So it does bring up challenges whenever we're talking about building out that data pipeline and how you want to kind of progress to it. And, there's not really any answers just yet to how it's all going to kind of go, because it's still somewhat fluid, right? Because like we know, if we look at what we're doing, let's just take TensorFlow, for example, right? So like what you're doing when you're setting up a TensorFlow environment, it might be something as simple as you're just setting up, different shares, so you have some NFS mount, right? Where you can just analyze, all this data, and, you're still orchestrating it and you're still going through that portion. But to build out those data pipelines, you might just have one data set, right? Or, one large set of that data. And so I think really what the key and what we're in maybe in 2019 and beyond is we're starting to look and say, hey, how can we bridge that data with what we have in our Hadoop ecosystem, right? Or what we have in other data sets. And not that I'm saying Hadoop's going to be the key to that, or, even, what we call in the Hadoop ecosystem, but it's still trying to kind of interesting to see how that plays out, right? Like, we're at this point now where we're taking advantage of what's going on from a GPU perspective. And, now we want to do like we do, with other projects throughout the years, right? That we've seen in the past is, can we marry this with other data that we have or other decisions that we've already made? So it's real interesting. And, there's, like I said, a lot of different approaches to it. And we're still kind of going down that path.
And I think your point, too, about the fact that deep learning is particularly applicable to these projects that are focused on rich media, as you put it, of video or images or audio, it starts to look more like a content delivery pipeline than necessarily the traditional data pipeline that we're used to, where we might be working more with discrete records or, flat files on disk or things like that have a lot of structured aspects to it, where there might be similarities between records that are conducive to different levels of compression or aggregation, whereas with video in particular, and even audio, there is a lot less of that similarity from second to second within the content, but also between files, because there are so many different orientations that are possible for an image frame or anything like that. So just conceptually, it requires a much different tack as to how you're managing the information and how you're providing it to the algorithms that are actually processing it.
Oh, 100%. I mean, we're talking massive amounts of storage, right? To be able to, if you, like I said, thinking about video data coming in, and most of that in its format, it might be compressed to some extent, but there's not going to be any dedupe or some kind of compression that we can do, for the most part, right? Like, one video file of a car driving down a road versus, a different view of that same one. It's not going to dedupe well. It's not going to have that. So there are some challenges there. But one of the things is, I did say, hey, when we look at it from a rich media type, traditionally what we did when we're talking about Spark and Hadoop and, anything in that Hadoop ecosystem is, it was still kind of text-based data. Well, it's still the same thing here. So I just want people in the audience to understand we're still breaking the data down. We're just breaking it down into, let's just say that we're doing grayscale, right? We're still breaking it down into matrices of, zeros and ones, but it's a lot of zeros and ones, right? For one video or one image or, anything from an audio perspective.
And particularly for formats like video or audio, where the information in relation to the other attributes of, the frame to frame is important and contextual, it makes it much more difficult to identify what are the logical points where we can split it versus something like a Parquet file, where if an individual file starts to grow beyond a certain set of boundaries, you can just say, okay, I'm just going to split it at this record boundary. It's not necessarily possible to do that with video or audio without compromising the value that you're getting out of it.
Yeah, I mean, So that's for sure. Like you're looking at it from that perspective of, being able to how you compress it or break it in, even though we're talking about massive amounts of data or large, data sets, being able to break those into chunks. But I mean, even think about it from a compute perspective when we're just talking about RAM, right? Like a lot of times whenever we're talking about being able to run a job or run some, maybe if it's a Spark image or a Spark job or a map, a traditional map reduce job in your cluster, you might have a ton of RAM, right? But, think about, I mean, we're talking at this scale, we're talking terabytes to petabytes to, I was just reading an article where they were talking about the predictions that we're at 33 zettabytes of data worldwide today. And by 2025, so less than 6 years away, we're going to be at 170, I think 175 zettabytes. And so like, I mean, it's just massive, it's just crazy just to think about how big the data is and how much data that we're creating from this. And I mean, it's also fun because we're changing the way that we interact with society out there. And we can get into, where we think AI is and where we think the boundaries are and how much of it is maybe hype or not. But I'll say that like my favorite thing to kind of talk about whenever we're talking about just AI as a concept is really it's just an extension of automation at this point. But it's just automation that we couldn't do, right?
And in terms of the actual responsibilities of the data engineer for the data as it's being delivered to these algorithms, particularly as it compares to machine learning, where you might need to do upfront feature extraction and feature identification to be able to get the most value out of the algorithm. My understanding is that with deep learning, you're more likely to just provide coarse-grained labeling of the information and then rely on the deep learning neural networks to extract the useful features. So I'm wondering if you can talk a bit about how the responsibilities of the data engineer shift as you're going from machine learning into deep learning, particularly from the standpoint of feature extraction and labeling.
Yeah. So ETL is not going away. So, there's still going to be ETL involved and there's still going to be, whether we call it data wrangling or data munging, right? We're still a lot of what I'm seeing and a lot of what we're talking about. And, I've talked to the chief data science officer, at SAS and, one of the things that he was saying is, we're still mostly doing supervised learning. So we're on the path of supervised learning where we have to have these trained labeled data sets, right? And so, data is still king and labeled data is still king as well, just because of that fact. We do think, in the next 5 years or so, we might start seeing more advances from an unsupervised learning perspective and just really seeing that. But there's still a lot of time. And I think there was a stat that was out there, and I wish I could credit who it was from, but I think 79% of a data scientist or a data engineer's job is still things outside of data engineering and data science. And part of that goes back to, there's a big portion of that that's, part of the data wrangling and part of the ETL that's involved. But then also one of the things, and, this is something as data engineers and, as we shift into, they've created a new role called the machine learning engineer, but it's around the same type of concepts. One of the things that we'll never get out of, and probably the reason we like being a data engineer versus a data scientist, is there's still a lot of importing, making sure we have the right software packages, making sure that this version, if we're using an NVIDIA card, that this version of Kudu and is going to work with the version of TensorFlow that we're trying to line up. So there's still a lot of that too, outside of just, making sure that we have the right data and making sure that we have the right data sets. And hey, if we're using some kind of storage, like, make sure we've allocated enough, right? Like if we're taking data that's off of a simulation, hey, do we have a big enough footprint to hold that 100 terabytes that's going to be written that needs to be read as soon as it's written too? So there's still a lot of fun things for us as data engineers to stay technical on that side, but there's new challenges with this too.
And for anybody who's in the early stages of a deep learning project, I'm curious what some of the edge cases or gotchas that they should be aware of are, and particularly ones that you've experienced yourself as you're working on these types of projects.
Yeah. So, some of the edge cases or some of the things to start kind of looking at is, it's a little bit of a different approach. Like I said, if you're coming from the Hadoop ecosystem and looking at that, it's at this point, it's a little bit, it's a little bit more simple, right? Like I was saying, like it's easy to get started, from the perspective of, hey, you can set up an NFS mount and just be able to, point your jobs at it, and, from a TensorFlow perspective or PyTorch, making sure, GPUs are going to be the big piece, right? Like, so, it's recommended, you install it and you use, the different packages with different GPU cards that you have. Can do it with CPU. Like if you're just trying to do a POC and you're just trying to do some testing to validate, hey, I know the steps to kind of go through it. There are some of those different libraries that you can use. Like I said, GPU for the most perspective there, and then there's a lot of installing and going back and forth. So making sure that you have checking your card with the latest version of Kudu if you're using TensorFlow or using PyTorch. And so I would look to that. And another thing to do is start thinking about how this is going to grow. So just like we kind of joked about in the Hadoop ecosystem is, once people start understanding that you can do big data, the whole, some of the reasons that these projects get funded are because, like we were just talking about it, that AI is a hot topic right now. And 4 or 5 years ago, Hadoop was the same thing. So those projects get greenlit, right? And you get funding to stand up those projects, but there's a lot of attention on you too. So there's going to be a lot of ask, right? Like, oh, hey, the analytics group down the hall, they're involved in a AI project. Oh wow, I'd love to get them to put some AI on mine. So you want to understand that and understand how that's going to grow. And kind of another thing, and you're seeing this go on just from a data engineer's perspective too. But this is on the forefront just because of where we are from a deep learning perspective. Containerization is huge. So if you're a data engineer, I know when we first started out in the Hadoop ecosystem, it was like, hey man, it has to be on bare metal. We can't even virtualize. And now we're going cloud native with Cloudera releasing different versions. So from a deep learning perspective, orchestration and management and just understanding containerization. Like if that's not something that you have, and that's something that I've been trying to catch up on, in the last year or so, I definitely make sure that you're up to speed on that because it's gonna play an important part. And so, like I said, there's tools out there that'll help you manage that orchestration layer. But on the back end, I mean, it's essentially containerizing, right? To be able to do your scheduling and doing everything kind of like what we've seen in the Yarn Hadoop ecosystem piece.
And in terms of the level of familiarity and understanding that's necessary for being able to build out the underlying infrastructure and work effectively with the data scientists on these deep learning projects, how much knowledge of deep learning and machine learning and some of the mathematics and fundamental principles behind it should we as data engineers be aware of in order to be able to continue to progress in our careers and work effectively as these types of projects become more prevalent?
So it's a super good question. I get that question a lot. Is like, hey, even just from the basics of, should I understand the algorithm? Should I know the algorithms? If we're talking about machine learning, if we're talking about deep learning, like how much should I be able to recommend and look at, TensorFlow? And it's such the software engineering answer, right? To say it depends, but really it does. It's going to depend, right? Like, if you're in a small organization and, you guys are just going down the path, you probably, maybe you have a data scientist, maybe it's more of a, data analyst in your organization, then you're going to want to be able to handle and be able to, carry some of that. Now, I'm not going to say that you're going to want to recommend, oh, we should use, CNN here, or if we're doing machine learning, like, hey, we should use, PCI or decision trees or from that perspective, but you definitely want to have a little more understanding around it so that when it comes to your part and your role in the organization, you can understand some of the tweaking and some of the kind of thought process around it and add something to the table. Now, in a large organization, right, that's maybe more mature in their analytics journey or their deep learning journey, then you're going to be able to focus. You're not going to have to focus as much on understanding the underlying. Hey, how does this math work, and what's the what are the weights and biases, and why are there so many different layers there? So you wouldn't have to focus as much in a larger organization. But I will tell you one thing that I've found, and like I said, I came from the data engineering side, and understood a little bit about the algorithms, but didn't really focus on them. One of the things that I like more about deep learning than machine learning is it's really a little bit different math. Like it's a little more basic too. I think I've heard people say that, whenever you're talking about it, you can get away with like, the first semester of calculus from a deep learning perspective versus with machine learning, it's a lot more complex, right? With the algorithms and kind of what you're doing. And a lot of it goes back to what we were talking about, how the data is broken up from a deep learning perspective. It's really just matrix math, right? It's matrix algebra to be able to stack all these ones and zeros, or if we're using RGB, ones and zeros and threes, and all these different pieces together. So we're using a lot of easy basic math. It's just really big math. So it's a long answer to say that it depends, but it really is it's gonna depend on your organization and kind of where your role is. So I would encourage you from a career perspective to be a little bit familiar with it. Just have a natural curiosity to it, but don't go. I wouldn't say that you have to go deep, right? You're not going to have to go back and get a degree, or you're not going to have to know the intricacies of everything about it. But especially with the algorithms that you're using, or the different neural networks that you're implementing in your organization, I'd be pretty familiar with there, but I wouldn't stand up and put myself as I'm the one that's going to recommend which approach we take.
And you mentioned earlier too about the possibilities of leveraging some of these deep learning capabilities in the data preparation and ETL processes. So can you talk a bit more about the different ways that we can leverage the capabilities that are promised by deep learning as part of our own work in the data management process?
Yeah, that's a good point. Whenever I kind of keyed on the point that we use supervised learning a lot, and just kind of to recap, if you think about supervised learning, that's where we have these, going back to our cat photos, right? We have a lot of images. Hey, this is an image that contains a cat. This one doesn't contain a cat, right? And so we know the end outcome we're looking for when we're doing that. And then I talked about how unsupervised learning is kind of on the forefront, and it's something that we're seeing. But you can use unsupervised learning to help out with some of your ETL and some of your data wrangling, right? So unsupervised learning is where we have hey, I have 1,000,000 images, and I just want you, I want you to be able to classify them, right? Like, you're going to feed them in. So this can help you to group. So I talked about, I don't think we're going to get out of ETL, and I don't think we're going to get out of data wrangling for a while, but you can use, like unsupervised learning to be able to pull and generate and put some kind of order to all this unstructured data we have too. And so think about it, kind of, one of the famous examples, that we've done before is like, sentiment analysis, right? So think about when you were doing sentiment analysis, if you've ever walked through a tutorial on Twitter. But now you can, think about that from the same perspective of, hey, there's, we can train a neural network to kind of just look at a whole bunch of images and kind of put all those to some kind of structure. And so if you think about it, if your job was to find these trained data sets, right, like you can use unsupervised learning to be able to, categorize those and put them in clusters, so that, hey, instead of looking at 1,000,000 pictures, maybe I'm only looking at 100,000, right?
And as far as how that plays into the infrastructure requirements and the processing requirements for actually being able to execute these ETL jobs as we're incorporating deep learning, what kind of an impact does that have?
Yeah, so from a storage perspective, there's a big footprint, especially when we're talking about, let's talk a little bit about the different environments. And so just when you think of your training environment, and this is where we're building out those algorithms, we're training, and we're hoping that, hey, if we're able to, what we're training our neural network to be able to do, the outcome. So back to our cat identifier, we're sending, millions of images through to be able to train those models. And so, to be able to do that, right, you have to have the storage or the output to be able to do that. And then you also have to have the throughput, right? We're talking about, from a perspective of, these are some of the most powerful chips on the planet, right? When you think about your GPUs. And so there's some specifically if you're doing things on prem, there's some requirements there from hey, how do you get enough power on a floor tile to these GPUs, right? Like, you're limited to how much power they're going to pull, right? And then there's heating and some of the other requirements. So there's a lot of processing that goes on in that part of the workload. And then when we flip to, okay, we've got our image, now let's train it out, in the real world and see if it's working. That's more in the inference, right? So that's where we talk about an inference environment. And so the easiest way I like to think about it is, if you're coming from a application development background, is you look at your training environment, think of that as kind of test dev, and think of your inference, as kind of more your production environment. And that's where you're really, really training, hey, we're going to feed you a whole bunch of images in there, and we're not doing any more training. And we're seeing, hey, can it identify a cat or not a cat? Or, can it drive down this practice road, right? Or do we need to go back and train it some more? And so, but with that being said, an application development environment, when you think about it, like, oh, your test dev, normally that's not your biggest footprint, right? But in deep learning, this is where the majority of your data lives, right? Because, like I said, you're trying to get the best amount of data and the most data into training these algorithms, so that whenever you go into production or you go out to test it in inference, you've made the best decisions.
And particularly in terms of the infrastructure layer, there have been a lot of new offerings coming out from the various cloud providers that are aiming to provide access to pre-trained neural networks or managed services around being able to execute these different deep learning algorithms and be able to pipeline data into them and out of them. So I'm wondering what your thoughts are in terms of the build versus buy decision around deep learning with the availability of these managed services, and then also particularly at the layer of ETL of does it make sense to build out your own additional capacity for being able to run these algorithms, or just start consuming these managed services at least as an initial step of simplifying and enhancing your capability to provide meaningful data processing and ETL for feeding into the end product that you're actually aiming for.
Yeah, no, I mean it's a good way to kind of look at it. It's like what you have whenever we're talking about, with the cloud providers, you have this, I mean, think of it as like a catalog sometimes of, hey, there's different approaches and different algorithms that I can use and turn it towards my data, right? And it really a little, think of it as a service, right? Like it's gonna almost be your data scientist, in the cloud, or data scientist behind your browser to say, hey, here's some data. Why don't you, test this out and see if, you can use this for your algorithm. With that, if it it's a good way to start, looking at things and seeing, hey, are things viable for what we want to do? But at the same time, we talk about the data gravity, like where does the majority of your data live, right? Like if the majority of your data exists in the cloud, and you're wanting to take part of these managed services, you just have to understand, from a business perspective, like, hey, you're offloading some of your data scientists or your data analysts, right? Like you're not having to make as much of an approach and a research perspective of, hey, we're trying to build out and trying to see, which algorithm is going to be best for our data sets. So it does give you kind of a guideline to be able to test out and be able to look at that. But then at the same time, if you had, if you have a lot of your data like on-prem and you've built your own systems there and you have your own research and your own talent in-house, then that's probably going to be the best approach for you, right? Like you're going to want to build your own systems and you're going to want to build your own algorithms because, your data is unique. And so it's not an approach that you want to take to be, hey, we're going to transfer and move our data up, or send it up into some of these managed services. So, it kind of goes back to, through the years, we go through different debates in different areas. Is like, hey, are we going to offload or are we going to outsource to consultants or anything like that? So it's really about how that you want to approach from that perspective. So for small teams that maybe don't have a data scientist, there are tools that are both on-prem and off-prem. It's the same kind of decision, right? Like how are we going to approach how we're going to build out our models? And do we want to, especially if you're just starting out, there's, products like Data Robot and other pieces that give you the ability to look and see what you're doing and give your data a test and a sample to say, hey, these algorithms might work for you, right? Like this might give you the answer that you're looking for. But from a deep learning approach right now, I mean, I think, we're starting to see those products and those tools come out as well. We've had them, like I said, from a machine learning perspective for some time, but you're starting to see those being integrated in a lot of tools. So I think we'll continue to see this debate continue, and we'll continue to see, product offerings in other maybe even analytic tools that are starting to take advantage of AI and deep learning.
And what is your personal litmus test for determining when it is useful and practical to use deep learning as opposed to traditional machine learning algorithms, or even just a basic decision tree for providing a given prediction or decision on whatever the input data might happen to be?
Yeah, I mean, so whenever we look at that, traditionally what I've seen right now, like kind of going back to what we were talking about with, it's really good when we're from a deep learning perspective, when we're talking about image data, when we're talking about, video data or audio files or, those kind of rich media types. I still see, for the most part, whenever we're talking about, like if we're looking for, just a classic example with like, hey, can you predict housing rates and, mortgage rates, or can you predict housing prices in a certain geo? A lot of those approaches, since you already kind of have the feature sets, they're really good to work in machine learning. It's not that you can't use them. There's plenty of examples out there to use deep learning for it. But traditionally, I still see that as the use case. All that being said, though, like I said, I still come from the data engineering side. So, if you're listening to the podcast and you're a data engineer and there's a data scientist in your organization too, maybe you should rely on them, but be curious about it too. Maybe ask them, hey, why, if it's different than what you think, kind of take that approach. But that's kind of what I've seen, and that's kind of my rule of thumb. But I'm not going to argue with a data scientist if they want to kind of test some of that out. And like I said, there's plenty of examples out there, but I still see, if we're talking about like some of the traditional, semi-structured, unstructured data, or data where we have all the points for us. That's not, video files or audio files or videos. Then, we can still stick with the machine learning approach.
And with deep learning algorithms, they're often a black box in terms of identifying what features contributed to the given decision that it outputs. And with regulations such as GDPR in particular, but others that are either active in different locations or in process of being formulated, they are introducing requirements to be able to identify what were the different factors that played into whatever the decision might be, especially when it impacts an individual. So how does that factor into your determination of what approach to take for a given project, as far as whether to use deep learning or machine learning or just a standard, Boolean logic-based approach?
Yeah, I mean, that's definitely an interesting question, and we think about it from any kind of regulation. We're talking about GDPR in this specific example, but if you think about what's going on from the, autonomous driving cars, right? Like, hey, at some point you've got to figure out, like, where do we make a decision for the car to drive into a brick wall or to, hit somebody on a bicycle, right? How can we go back and kind of prove that? And then it's really the regulation, maybe not even the technology, that's going to, because that's going to keep me driving. So same thing here. We're talking about, can you go back and prove, which weight and which bias that we had from a deep learning perspective? There are ways whenever you're looking at the neural networks to be able to do, back propagation and kind of look back and see, okay, where did we weight one feature, or, how does all that kind of work? I don't know from a legal perspective how that would kind of play out with GDPR, right? Like, what's the level of proof that you would need? But yeah, those are definitely, different challenges, that we're looking at from, like, not even from a data engineer's perspective or from a data scientist, but like, we're all like, these are our projects, right? Like, we're all involved in this conversation as well. So those are all, like, interesting points, but I don't think it's something that, that we're going to be able to solve. But from the GDPR, there's so many different layers to that. We think that, from a regulation perspective, being able to take and being able to, go back and say, hey, okay, we have different data elements that aren't going to leave, this specific border, this specific, GPS coordinates, right? Like, data's going to stay in the country in which it originated. Well, how do you take data that's been originated in a country, but you've trained models on it and you've deployed the model otherwhere, right? Like, you're not moving the data, but how, how does all that kind of tie in? So those are huge points, huge things that we'll see play out for years and years.
It's a whole big ball of yarn to try and untangle, and then there are the aspects of bias in terms of how the different features are weighted and what the training data has in terms of inherent bias because of how it's collected or how it's represented. And that's something that is an ongoing conversation, and one that I don't know that we'll ever find a complete solution to, but something that is definitely useful to keep in mind as we build these different products, because it's important to be thinking about it even if we don't have a perfect answer, because don't let the perfect be the enemy of the good, especially as it pertains to people's privacy or rights or inherent biases and how they're represented in the software and projects that we build.
I think that could be like a multi-part, maybe even ongoing podcast for your episode to have, right? Like, just peeling back the layers of GDPR and what's our responsibility, and, just things to think about, right?
And for anybody who wants to learn more about deep learning from the perspective of a data engineer, or who might be interested in deploying it for their own projects or building projects based on it, what are some of the resources that you have found useful and that you recommend other people take a look at?
Yeah, so like I said, started out with the machine learning course from Coursera. I'm actually going through right now the deep learning bootcamp. I think it's like the deep learning AI. So it's Andrew Ning's course around it. Python development, really cool hands-on with TensorFlow. So that's been very interesting. And then from my own perspective, so like I said, I'm a Pluralsight author, and one of the things that I went through and did last year is, and I released it this year, was did a data engineers course on, kind of TensorFlow, and I used something called TF Learn, which is an abstraction layer for TensorFlow. And so it just gives you the ability to just think of it as, from a data engineer perspective, like, think of how we went with Pig Latin, right? Like, Pig Latin could take you from 140 lines of Java down to, 8 or 10 lines of code. Same thing from a TF Learn perspective. So I've went through, I've created a course specific to data engineers and how to kind of get started with, hey, build your first neural network. So a lot of resources around that. Like I said, there's a lot out there on Coursera. There's some free courses as well on Google. Google has a machine learning boot camp, and it kind of goes through. I think they say it's like 30 days or something like that. But I think it's something I was able to knock out in like 2 weeks. It offers labs and everything, and gives you the explanations, and there's little quizzes in it too. So there's a lot of resources out there. It's very popular. Huge documentation out there for TensorFlow. So just get out there and start looking at it, and just if you don't understand it, it's okay, right? Like that's the thing. Just get in, start learning it. After you keep going through repetition, you'll start to understand it.
And are there any other aspects of deep learning from the perspective of a data engineer that we didn't discuss yet that you think we should cover before we close out the show?
No, like I said, I think the three biggest things I would look to from a data engineer's perspective is just kind of watching what's going on. Projects like Submarine, Sparks, Project Hydrogen, and then looking into what NVIDIA's got some documentation and some blog posts out there on what they're doing with NVIDIA Rapids. I think that's going to have a huge impact on our day-to-day jobs as data engineers, just from the aspect of, hey, speeding up some of these ETL pipelines, and then also being able to access what's going on, whether it be TensorFlow or PyTorch or Caffe.
All right. And for anybody who wants to follow along with you or get in touch or see the work that you've been doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, so the biggest tooling and the biggest gap probably for data management, it's going to be in the ETL arena. I mean, it's something it's how I started out, right? Like I said, I volunteered for a job, and I volunteered for the job. I didn't have experience in data engineering, and I didn't have it in the Hadoop ecosystem. So my first job was doing ETL, right? And we keep going through the years saying that, hey, this is something that we're going to fix, right? Like, hey, we have this tool or that tool, and I'm not saying it's not getting better, but I mean, I think it's one of those things. Until we can train the machines to do it for us, I think it's always going to be something we do.
All right. Well, I appreciate you taking the time to join me and share your experiences working with deep learning and how it plays into your work as a data engineer. It's definitely useful and interesting to get that background and keep an eye on different areas of concern for people working in the industry. So I appreciate that, and I hope you enjoy the rest of your day.
Oh, you too. Thanks.